17 hours, 57 minutes, and 3 seconds until the Great Tennessee Eclipse takes place.
Is that the start or end of totality?
Yes, it is. To the start or end. I think it's to the start, I think. Yeah. Totality. So it's the start of totality or the middle?
That's to the power.
To totality. Okay, so start. So anyway, this is kind of cool. I don't really know. So on this page, actually, the observatory page, it's mtsu.edu/observatory. We have the first Friday star parties listed, so we have the current schedule. There's some directions and things in case you don't know where you are now. And then we also have a nice image collection. So we have a lot of things that have been taken by students, some pictures of the observatory and of planets, Messier objects. So all these images were taken at our observatory. So it's kind of neat if you want to go and take a look at some of the stuff we've been doing. It's a great place to go. So let me actually go to here. So it's again mtsu.edu/observatory. So let me go to that. There we go. So today I'm going to talk about eclipses in a historical and kind of spiritual sense, in some sense, but mostly talking about the connections between eclipses and really deep emotional resonance. So we're going to talk about how eclipses kind of really resonate with people. So this is a picture from one of the eclipses, and you can see this is kind of a scary thing to look at. If you're expecting to see the sun in the sky, and this is what you're looking at, you will be filled with fear. There's just no way around that. And the thing that this gets to is the idea of the power of an eclipse to really, kind of, again, influence people emotionally. So that's the thing I'm going to talk about, and also the history and the things that eclipses have had, over the time. All the talks this semester that are the star parties are about eclipses because we're kind of preparing for this. On August 21st, we are going to darken the sky for you. We are going to blot out the sun for your entertainment. Yeah. We will do that because we like the community, and this is outreach. Okay, the thing that I'm going to say about this is it's going to be a fantastic, once-in-a-lifetime kind of event. How many people have seen an eclipse before? Okay, a few people? Cool, awesome. So eclipses, and we'll talk about probably the one you saw, which is probably 1971, that went through the southeastern U.S. So, it's just an amazing thing that's going to take place. We're going to have a huge event on campus. We're expecting 5,000 guests. You're all invited. We get 1 minute and 5 seconds of totality here. So this is actually just a map of some of the eclipses that are coming up. And the one that we're going to get is coming through, again, August 21st, 2017. It kind of goes across most of the continental United States and comes back down. There's another one in 2024 that actually goes past through here again. But it's rare. The last one that really went across the U.S. Was 1978 for a total solar eclipse in the U.S. There's been a couple others. There's this one up here. We'll talk a little bit about this one in 2015. So they happen on a kind of regular basis, but not usually too many places because you can only see a total eclipse if you're really in the path of totality. This is where the path is coming up on August. So we have it going right through the center of Tennessee. We're right on the edge here, but we still get about 1 minute and 5 seconds of totality. If you're in the center, you get about 2.5 minutes. So if you're up in Lebanon or a little closer up to Nashville, you get a little bit longer time. But still, 1 minute and 5 seconds is a lot, and we'll have all the telescopes out. We're going to have a big presence. It's going to be a party, and you guys are going to bring the food. So that's going to be cool. So eclipses basically are simple. The idea of an eclipse is what you're seeing is something going through the shadow of something. So the diagram that I have up here is actually a lunar eclipse. And what you're seeing is the sun over here on the left side, and then we have the Earth, and we have the shadow of the Earth over here, and this is the moon. So the moon is going through the shadow of the Earth. And this is a lunar eclipse. Now you'd think when this happens that everything would go completely dark and you wouldn't see the moon at all. Well, it turns out there's something else that happens. By the way, this is the partial shadow thing. This penumbra, this bigger gray thing, is a partial shadow. So the penumbra is where you're going to have a little bit of an eclipse. The moon gets a little bit darker. It's actually not very spectacular. Just out of curiosity, but does anybody know when the next eclipse is? It's not August. It's actually February 15th. So, but the trouble is, it's a penumbral lunar eclipse. So it's not going to be a total lunar eclipse. It's going to go in through the shadow and get ever so slightly darker. And if you look really hard, you can see it, sort of. So I don't get too excited about penumbral eclipses because I can never tell if it's actually eclipsed or not. But still, it's going to still go through the shadow of the Earth. The reason that you don't actually see a completely dark moon during a lunar eclipse is the Earth's atmosphere actually refracts light onto it. So what happens, it's just like sunset, the moon gets actually really reddish in color. So what you end up with is kind of a blood red moon, which is, I mean, it's kind of scary. It's what it looks like. So it looks really reddish in color. I think I have a better one here. So this is actually, you can see the shadow of the Earth. They track the shadow, and you can take these pictures. So this is what it normally looks like, and it looks blood red. And, you know, this has been called blood red throughout history. When people see this, it does, if you don't know it's coming, it does kind of freak you out because it doesn't look like a normal moon. There's something wrong with it. So, you know, this, again, is even a lunar eclipse is a really powerful thing. When you have a solar eclipse, it's even more dramatic. A solar eclipse, you know, it gets completely dark outside. You see the stars during a total eclipse. And, you know, we know when this is coming now, so we don't get as excited as ancient man did, but we still have a lot of things. So here's the geometry of this. So basically, again, we have the sun far over here, and we have the moon, and the moon's casting a shadow on the Earth. Now, the sun's really big. The moon's not really big, so the shadow path is actually pretty small. It's about 100 miles across, more or less, depending. Sometimes the main shadow doesn't even touch the Earth. It's called an annular eclipse. So an annular eclipse is what happens here. Let me move over here. An annular eclipse is what happens here when you still see the edge of the sun. So this looks like it would get really dark, but it still is pretty light out. It still looks kind of like daylight. It's just darkened a little bit. So this is a total eclipse. Partial eclipse is when you just have part of it taken out. But we're going to get one of these. So the sun's going to go completely out for 1 minute and 5 seconds, and then it's going to return, again, assuming you guys bring food. So that's really good. So this is what it looks like from space. So I thought this was kind of good. This is actually a shadow of the moon getting cast across Earth as viewed from space. This is taken from the Mir space station. So this is what's going across the Earth, right, is this giant shadow. Now, there's still dark in other places. It's not quite as light because we're seeing some things getting blocked off. But still, this is kind of what it looks like. So, and this is going to be passing over Tennessee. Again, partial eclipses happen all the time. I've seen a lot of partial eclipses. I've only seen one total eclipse. And that's, you know, a different thing. Annual eclipses, again, are a little bit, you know, happen as well. But an annual eclipse is not the same as a total eclipse. When you have totality taking place, the last thing that happens is that the moon goes right in front of the sun, and there's a little tiny bit over on the corner that's left over. It's the last bit of the sun. And this is called the diamond ring effect. So this is going to happen, hopefully, you know, hopefully again we'll have clear weather. We'll see the moon going in front, and then we'll see this diamond ring effect as it's going through. And then it'll go completely dark, and it goes completely dark pretty rapidly. I might just mention another thing about eclipse geometry is how this works, because, you know, we have the Earth's orbit and we have the moon's orbit. You might wonder why we don't have an eclipse every single month. And the answer is the moon's orbit is tilted just a little bit compared to the Earth's orbit. So it's about 6 degrees different. So the only time you can actually have this happening is when the moon's just crossing the ecliptic just the right way, and it's perfectly aligned, and then you have the possibility of a lunar eclipse over here, or, sorry, lunar eclipse here, or solar eclipse at new moon. So solar eclipses take place at new moon, lunar eclipses take place at full moon. But you only can have it if the orbits are just perfectly aligned. And there's actually a cycle of this. The moon's orbit cycles around about every 18.6 years. So it's kind of tricky to predict these unless you have a lot of observations or a lot of computing time. So this is a picture of solar eclipse taken in, this is actually taken in the northernmost island of Norway. I think it's Svalbard. So this was 2015. And people went to this place to look at the eclipse. Again, this is, I think, the farthest north inhabited island on Earth. So they had about 3 minutes of eclipse time. This is actually my first eclipse, 1979. This is a path the moon took across thing. So I'm from Minnesota, so Minnesota's here, and I'm from this place in Minnesota there. And we took a car, and we went up here, and we went like, up there. And that's what we saw. So we saw a total eclipse. This was February 26, 1979 in Minnesota. Now, you might think it's cold in Minnesota. See what it's like when you try removing the sun. Okay, it got really cold. But it still is one of the most incredible memories, in my life. It's probably one of the reasons that I actually got into astronomy. It was that sort of influential on how I view the world and how I view the universe. This is the one that a lot of you saw. So again, how many people saw 1970 eclipse? Anybody? This went through this is the last one to go through the southeastern U.S. This was a total eclipse that went through Georgia, South Carolina, North Carolina, and Florida. So what other eclipses have you guys seen? Has anybody seen any other total eclipses? Which one did you see?
I saw in Russia.
Russia, okay. What year?
Oh, I was 8 years old and I haven't seen it by force.
Okay, that's fine. That's fine. Fair enough, yes, fair enough. Yeah. So again, most of you haven't seen a total eclipse. It's kind of different than what do you think? So I'm going to show you what a total eclipse looks like from the point of view of observers. So I'm going to do this one. So these are all little links to things. I'm going to make sure the volume is set here. Yeah, there we go. Now I'll ask me later. You have to be kidding.
Wow! 20 seconds!
Oh, I got corona. I got corona. I have corona.
Yeah. There it is! 10 seconds! Woo!
Diamond ring!
Diamond ring!
Diamond ring! Look! Oh my God! Whoa! Oh my God! Look! Providence Falls!
Wow! Woo! Oh my God! Oh. Woo! Wow!
Look at it. Oh, look at the curl of the shadow. See? Look at this. This is the shadow. Like this. Look at that.
Wow! Look at that! Oh my God!
About 3 minutes.
Wow! Look at that, man! Oh my God! Is that beautiful or what? I got
Just incredible.
You can see the shadow lines.
lots of time. Lots of time to look
Look
at
at
it.
how gorgeous it is. Look at the sky. Look at the
I
sky.
know. Look at that.
the umbra.
Yeah, you
Look
can
at the
see it.
umbra.
Yeah, it's it. Yeah. Yeah, I see it. Yeah. Wow.
Oh, look, that's a cool corona, man. Look at it shooting off like that. Right above the,
Yeah.
Oh, it's so killer.
Wow. Oh my God. Look at it. Wow. Oh my God, that's so beautiful. Look at that. That is so beautiful. Wow. Oh, my battery died, but whatever. Dave, you want to look through? Yeah. Here, real quick. Go ahead. Go ahead. Focus is on the. Oh my God! So long, like we got.
Oh, that's so sweet. Look at the prominences. Killer corona. Oh, man, that's so nice. Oh, look at the prominences in the bottom.
Yeah.
Right at about 6
I see
o'clock.
it.
Quick.
Wow. Oh, I got the diamond ring. Whoa! Wow! I'm just
Look at the upper going that
You
way.
can see it. Yeah, you can see it.
Look at the whole shadow
Yeah.
moving this way.
Yeah. Wow! Oh, wow! Look at that!
So I guess my point is that people actually have an emotional reaction to this. So you laugh. Wait till August. That's going to be you. You're going to be screaming like a little child. What was a word that you kept hearing over and over again? The phrase you kept hearing? Oh my God. Right?
Yeah.
That's because it's a deeply amazing experience. So let's talk a little bit about history. So this is actually one of the an image, a Chinese image from one of the first eclipses. And what you're seeing is the dragon. Okay, I'm not sure. You get dragon out of that. Sufratra eating the sun. So this is, they didn't really know what was going on. So they thought that a dragon ate the sun. And as a matter of fact, eclipse basically is, the root is eating. So it's something, the sun being eaten. So this is, again, an old thing. The first records go actually a little bit before this to about Sumerian records, about 1500 BC, first written records that we have of eclipses. So we've known about them for a long time. The ability to predict them might actually go before that. Now, written records, again, go back 3000 BC or so. But this is actually a diagram of Stonehenge. And on Stonehenge, you have this inner circle that everybody goes to, this kind of thing up here. And then you have this outer circle, which is the henge. And then just inside the outer circle, there's this other little thing here, these other little post holes. And they've dug up and they've done excavations and they find these other post holes. And it turns out that if you use the post holes and these other holes that are right outside the circle in the right way, you can actually use that for predicting when eclipses are likely. Now, again, we're mostly talking about lunar eclipses, but there's a cycle of lunar eclipses. So you can use this for predicting the positions of things. And the idea is that you have a moon marker and you have a sun marker, and by putting this together, you can actually tell when the alignments can be favorable for eclipses. So kind of a cool thing that, in Stonehenge, there might have been a capability. Now, it's not obvious. It's not completely sure. The numbers on these circles are pretty, strange because there's like 56 holes here, and I can't remember, 23 holes there. So the numbers happen to be the right kind of cycle for this. So again, not 100% case, but it's definitely possible. Now, again, we move the node marker every 3 years, it goes around, and you move the other markers, and it just kind of works out. If you go to the Bible, actually, I did a Google search on this. There's about, I think about 180 references to the sun, about 62 references to the moon, and if you read them, there's about 8 indications of the moon and sun going out. And this is what they usually sound like. The sun became black as the sackcloth of hair, the moon became as blood, the moon became as blood, the moon became as blood. And it's because it's a lunar eclipse they're talking about. Now, this is usually, prophecies. So they're talking, but they're thinking about what is the scariest thing they can think about. And the moon turning blood red, which they surely have seen, scares them. So this is an apocalyptic sign. Also, the sun be turned into darkness. There is some history or some rumor that the sun goes out at times when this was written. So there's definitely these kind of connections going on where they're thinking of a deeply emotional event. Those stories have been passed down generation after generation after generation. And then, incorporated into prophecies to kind of talk about, how this would appear. Revelations, sun is black as sackcloth of hair. That's a pretty scary way of thinking about things. If you look at other things that are related to eclipses historically, one of the things that you come across is there's a couple references to eclipses in the Quran. One is that an eclipse foretold the birth of Muhammad, not that it wasn't the same time. And Muhammad's son apparently died during an eclipse, an annual eclipse of the sun in 632. Now, they didn't view this as necessarily miraculous, but because they didn't think that God, did things just for puny humans, that this just happened to be a coincidence that this happened. So it's interesting. It's kind of an interesting way to think about prophecy. one of the things is death of Henry I is another one. So this is probably, again, not a coincidence. So there's a total eclipse that went through England in 1133. So this is right after William the Conqueror. This is William the Conqueror's son. And William the Conqueror's son was ruling England. He was doing fine. He was getting to be kind of an old man. And then the sun goes out. And he dies during the eclipse. Because he was scared to death. I mean, he was scared to death. The sun goes out. It's a frightening thing. If you don't know that's coming, it's going to be terrifying. Good thing that we're here to tell you. So, one of the efforts to do early predictions, after Stonehenge, we're not sure again if Stonehenge was really used for predictions or not. But this is kind of a cool thing. This is, and I always have a hard time pronouncing this, antikytheric mechanism. So this is probably the coolest piece of technology in the world. My biased opinion. So the reason I say that is, first of all, it was dug up in 1902. It was actually underneath the Mediterranean Sea. It's from 76 BCE. And it's not what you're looking at now. It's what it looked like when it was operational. So they remade this. They actually did X-ray scans, and they found out all the things in it. And what they found was gears. So they found a geared mechanism from 76 BC. And the 76 BC mechanism would have looked like this, except with not as much plexiglass. Okay. So, but they've been able to reconstruct this. They had to come up with 1 or 2 gears to fill it in. But this was used for predicting eclipses. This could predict the motion of the planets, the motion of the sun, and also predict when eclipses were likely. Did I mention this is 76 BC? So if you look at early clocks come in the 1400s. Okay, so 1400s. So this is 1400 years before clocks. And there's about 30 gears in it. This is like finding a starship in the Civil War. Okay, so I just am blown away by this. If you think about Archimedes, you know the myth about Archimedes, don't disturb my circles, and when he was killed by Roman soldiers. When he was talking about circles, they were really talking about gears. He was a guy that made geared mechanisms. So by doing the ratio of circles, he could actually use this for prediction of different things and doing mathematical calculations. This is an eclipse that's a lot later than that. But eclipses out throughout history, so you think about early prediction of eclipses, Henry VIII, but this is, again, English. This is actually Halley, Edmund Halley, who went to an eclipse basically to get a chance to get observations of it. Now, to do this, this is taking place in 1716. In 1716, if you wanted to go around the world, it turns out that the jets weren't really there yet. So yeah, just hold up for a second. Just put it over in the corner there for right now. So Halley went all the way down here and actually did observations of an eclipse all the way, down here, and he reported on in the Royal Society of Transactions. So, this is getting to the point where world exploration is taking place, and we can actually start getting data on them. This is probably my favorite historical eclipse. Does anybody can guess where this picture represents? Yeah, it could be. It sounds like it could be Babylon. Let me give you another hint. How about this one? So Christopher Columbus was on his 3rd voyage. His ships were basically broken, and he was kind of stranded for a while. So he was living in Jamaica, and he was basically relying on Native Americans to feed him. And his sailors were not behaving. They were really being terrible to the natives, and the natives got tired of it, and they stopped feeding the sailors. But he had an almanac that told him when a lunar eclipse was coming up. And he announced to everybody, hey, my God's angry with you. In 3 days, I'm going to turn the moon, my God's going to turn the moon blood red because you're not giving us food. And they just laughed at him. 3 days later, the moon turned blood red when it was rising. And everybody was just frightened. So they ended up giving them food. So yes, this actually happened. Columbus actually used an eclipse to blackmail Native Americans for food. So, this is the actual thing that if Connecticut Yankee in King Arthur's Court has that kind of scene in it, this actually is based on what Columbus did. So that's just a short overview of some of the historical events that eclipses have been associated with. The point that I really want you to understand is that you have to see this. You cannot miss the eclipse in August. You have to go outside and see it. It is going to be one of the most amazing things you will see in your life. So, we're going to predict this. We're going to do this for you. It's going to be great. But you might want to bring us dinner. So I want to do one. I want to do questions in a second, but I want to do one quick thing before that. Today is my wife Catherine's birthday. So you ready? So first of all, some flowers. So we have cake for everybody up front. so we'll do questions now, and then we'll have cake right afterwards. So any questions? Yeah.
Well, what I remember kind of as a story is that Einstein had predicted that the sun would bend light, and they wanted to get pictures of the stars behind the sun.
Right.
And the first 3 times he tried it, the clouds came and nothing happened. And the 4th time he was finally there, they said, "Do you want to look through the telescope?" And he said, "No," he said, "I know what's going to happen."
Yeah, he didn't actually go to the eclipse, but yeah, he did predict what was going to happen. So the sun's gravity actually bends starlight. Now, it's very hard to see because, daylight. And so you have to wait for an eclipse to take place, and you have to take an image of the sky and measure things. So it's called the Eddington experiment. And we actually thought about doing that experiment here. I guess there's some technical difficulties associated with that.
We're still planning to give it a shot.
Okay. So doing a modern measurement of the bending of starlight is possible, but it's a difficult experiment to do. But yeah, it was a confirmation of general relativity. So the first confirmation of the bending of starlight from general relativity was using a solar eclipse. 1911 was the one that we did actually. So.
Are you going to arrange for it not to be raining?
I would really like to do that. I could just darken the sky. I can't do the clouds. I'm sorry. Sorry. Got limits. Limit power.
There's probably going to be a lot of people with cameras. Would
Yes.
you mention briefly what not to do?
Don't look at the sun. Except when it's totally eclipsed. During totality, you're absolutely fine looking at the sun. Now, when it's totality, when it doesn't appear bright to you at all, when you see the little glowing thing around it, then you can look at it. It's the only time you can look at the sun. Even a small partial eclipse, it's amazingly light. There's a lot of energy coming from the sun, so don't ever look at the sun. I don't care if there's an eclipse going on or not. Staring at the sun, you go blind. That's just what happens.
Well, if you have a telephoto lens,
Yeah, so telephoto lens,
it'll burn your.
yeah, it'll wipe out your back of your camera. Yeah, it'll just burn through the back of your camera. So even partial, except during totality again. So, because it's a magnifying glass, it's going to focus on the back of the thing, so it'll burn through the back of your camera before totality. If you put a solar filter on it, there are special solar filters you can take pictures. We're going to be putting things up on the big screens, and we're going to have lots of stuff outside too. We expect a really big crowd. Like I said, we're hoping for 5,000 people. Tell your friends, bring them. So.
What about a regular film camera? It won't hurt the film.
Oh, it'll burn through the film.
Yeah.
It'll burn through the back of your camera.
But it won't hurt the digital screen of that one.
Yeah, it won't hurt the back of the screen. It'll burn through your camera, though. I mean, you're focusing. It's like taking a magnifying glass and then focusing the back of your camera, so it'll melt it. Yeah, so that's bad. Yeah. Any other questions? Yeah.
I'm updating my calendar. What time on this?
It's in the afternoon. I think that's about 1:30, if I remember right. So in the afternoon. We're going to be here all day. We've booked our guest house out,
It's also a move-in weekend here, I believe. So, or like the first day of classes, maybe.
It's a week before the first day of classes. We thought it was the first day of classes, and we just went into a panic. Can you imagine first day of classes and the sun goes out? The poor freshmen. What would they do?
One more question.
Yeah.
There's an observatory in Hawaii that takes regular pictures of the sun, and it sort of blocks it out to make it look like an eclipse when it's not.
Yeah, there's a thing called a coronagraph, which basically you're blocking the disk out. If you have a perfectly shaped disk in just the right way, you can get it so it blocks the light out and you can just see the outside. And we have a bunch of satellites that do that. It's easier to do in space because the atmosphere is a little bit easier. But yeah, that's the way that we actually measure the outer atmosphere. What you're looking at, by the way, here is the outer atmosphere of the sun. We're going to have some stuff in the science of eclipses later on. So you're seeing this little red area. That's a chromosphere, and this outer part is a corona. It's the glowing outer gases. So this is actually a really hot region of gas. This is a cool region of gas in the out stuff. You can actually see flares and prominences and all this other stuff that you normally can't see. So it's there. It's just really dim compared to the brightness of the sun's surface. Good questions. Yeah.
Is it true that the corona is hotter than the sun?
Yeah, the corona is hotter than the sun. The corona is 1,000,000 degrees. The surface of the sun is about 6,000. So if you look from the center of the sun going outward, it starts about 15 million, then it goes down to about 6,000, and then it jumps up to 1,000,000 again, which is weird. And the reason it does that is magnetic fields. Magnetic fields from the sun are actually heating up the low density gases. It's really, really low density gas out here, but it's also really hot gas. Yeah, so it's very, 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 very thin gas. Yeah, good question. Any others? In the back, yeah.
Is there eyewear you can acquire to look at the before and after mortality?
Yes, so we will have eclipse goggles.
5,000?
How many do we order on? I think we ordered 50,000. Yeah, we're going to be giving it to school kids. So yeah, we're going to be giving a lot out. We're not kidding, 50,000 goggles. Yeah.
You can use welding goggles, the kind for oxyacetylene welding, not the electric welding one.
I don't recommend you use anything other than actually, things approved for the eclipses, but there are other things that probably work, but I would just be very careful. So we're going to have 50,000 of them. You can get one from us. It'll be okay. It'll be okay. We'll have some extras. It'll be all right.
Did you get a grant to buy them?
Actually, we got some internal money. This is going to be a big event on campus. Yeah. Yeah. And actually, we'll probably have food, I think, too. Yeah. We're going to actually bring food for you guys instead.
Good advertising for physics and astronomy.
Yeah, we thought so. Yeah. I mean, yeah, we don't get to do this very often, so. Yeah.
And how long before August 21 will the goggles be here?
I don't know. We'll have them this summer sometime. We have them on order now. So it's interesting. These companies have been advertising for this eclipse to place your orders now for the last 3 years. So if you waited until July to try to get them, you couldn't. But we're going to have lots available. So we'll be we'll have a lot.
Will be available for the dedication of the science building?
I don't know.
They will be.
They will be. They will be.
I made them.
Okay. Okay. So we're going to have eclipse goggles for. All right. Awesome. Nice.
Do y'all know any more activities that are going to be that day?
We're working on it right now. The range of things go anywhere. We're going to have some talks going on. Catherine and I were looking at getting an improv group here. Science improv. So we're going to have lots of things going on.
Bouncy house?
Yeah, bouncy house. There might, no, you don't want to do a moonwalk during an eclipse. It just, it's too confusing. Corona party the night before. Yeah, there you go. Yeah, my house is going to be filled with astronomers, so there's going to be some talks that week. Any other questions? So if you have anything else, come on up, and we have cake. So let's sing happy birthday to my wife, because that'd be really fun. Happy birthday to you. Happy birthday to you. Happy birthday, dear Catherine. Happy birthday to you. Woo!